everyone, myself Sravanthi, working as an assistant professor in data science and cybersecurity in MLR Institute of Technology. Today our topic is conversion of NFA to DFA. Okay, so the given NFA we are going to convert it into a DFA. So as we have already discussed, we cannot convert DFA to NFA, but we can it is not possible DFA to NFA, but NFA to DFA conversions can be done. DFA to NFA conversions can be done. So what are the steps required to convert an NFA to DFA diagram? So first, convert the given NFA to its equivalent transition table. Transition table is nothing but there are 5 tuples. In the 5 tuples, we are going to have a transition table like delta table we are going to have. Then after, create the DFA start state. Now after that you identify the start state, and then after you find out the transition tables for DFA diagram, and you find out the final states. You construct a DFS final states. The only difference will be here when we are going to construct a transition table for DFA, we are going to find the new states. So the new states are going to be derived until I don't find a new state. Until I don't find any new state, I am going to derive it. Nothing but derive it is nothing but we are going to find the transitions for the every new state. So let us go for an example. So this is the example. Q0 on 0 input, it is having Q0. This is what type of diagram? By looking into this diagram, I can tell it is as a NFA diagram. Because in a DFA, we will be having only, each state will have at least 2 transitions. On each input, only 1 transition should be there. See here, Q0 on 0, there is a transition on Q0, and Q0 on 0, I am having a 1 on, it is moving to Q1 also. Nothing but there are multiple states are there. Multiple input symbols for a single state. Okay. So this is nothing but NFA diagram. Now we are going to convert it into a DFA. This is the NFA diagram. Okay. So the first step is we are going to find out the transition table. See here, we are going to find the equivalence transition table. What are the tuples I have? Q, sigma, delta, Q0, comma, F. These are the 5 tuples I have. M equals some machine I am using. M. Okay. So what is Q? Q is pointing to Q0, comma, Q1. And sigma is nothing but what are the inputs I have? 0, comma, 1 are the inputs. Q0 is nothing but what is the initial state? Q0 is my initial state. What is your final state is Q1. Q1 is my final state. Let me draw the transition table. So delta. So what are the inputs I have? 0, 1 are the inputs I have. What are the states I have? Q0, Q1. So Q0 on 0. Where it is going? Q0 on 0. It is going to Q0. And Q0 on 0. It is also going to Q1. Next. Q0 on 1. Q0 on 1 input. It is going to Q1. Next, Q1 on 0. Q1 on 0, any is there? Not there. So it is nothing but pi. So Q1 on 1, it is going to Q0 as well as staying in Q1. So this transition table is for NFA. This transition table is for NFA. Now let us construct transition table for DFA. We are going to construct transition table for DFA. So let me construct here DFA 0, 1. So Q0 on 0, where it is going? Same thing. Q0 on 0, it is going to Q0, comma Q1, and Q0 on 1, it is going to Q1. Q0 on 1, it is going to Q1. So what it is? So after constructing Q0 state, I am finding 2 new states. What are the 2 new states I found? Q0, comma Q1 is one state and Q1 is the other state. So by nothing but how we are going to construct a DFA transition table is, if I find a new state, then I am going to derive that new state by using these inputs. Here these are the 2 new states. Q0, comma Q1 is one new state and Q1 is the other new state. So until when I will derive? Until I don't find any new state, we are going to derive this. So the first new state I have is Q0, comma Q1. Q0, comma Q1 on 0 input. So let me construct. So delta dash of Q0, comma Q1 on 0 input. Delta dash on 0 input. Let me write it. Delta of Q0, comma Q1 on 0 input. So what I am going to have? Delta of Q0, comma 0 union delta of Q1, comma 0. Delta of Q0, comma 0. Q0, comma 0. What I am going to have? Q0, comma Q1 union Q0, delta of Q1, comma 0. Q1, comma 0. What I have? Pi. So pi into something is something. So nothing but Q0, comma Q1. Q0, comma Q1. So this is nothing but delta dash of Q0, comma Q1 on 0 input. We are going to get this one. So on Q0, Q1 on 0 input, I am going to get Q0, comma Q1. Similarly for Q0, Q1 on 1 input. Q0, Q1 on 1 input. Delta dash of Q0, comma Q1 on 1 input. So 1 input. What it is happening? Delta of Q0, comma 1 union delta of Q1, comma 1. Delta of Q0, comma 1 union Q1, comma 1. Q0 on 1. Where it is going? Q1. Union Q1 on 1. Where it is going? Q0, comma Q1. So we won't write in union. Duplicates cannot be written, as we have already discussed in the basic terminologies of automata. Okay. So what we are going to have? Q0, comma Q1. So Q0 on Q1 on 1 input, I am having Q0, comma Q1. I didn't find any new state in Q0, comma Q1. So the other new state I have is Q1. So let me find out the delta dash of Q1, comma 0. Delta dash of Q1, comma 0 is nothing but delta of Q1, comma 0. Delta of Q1, comma 0, what I have? Pi. So Q1 on 0 is nothing but pi. So next, delta dash of Q1 on 1 input. Q1 on 1 input is nothing but delta of Q1, comma 1. Delta of Q1, comma 1 is what I am having? Q1, comma 1 is nothing but Q0, comma Q1. Q0, comma Q1. Q0, comma Q1. Q0, comma Q1. Okay. So the next I am having is, did we find any new states? Yes, we found the new states. What are those new states I have found? So in the first state, check the first state. Q0, I have two new states, Q0, comma Q1 and Q1. So these two new states are completed. Let me draw the same diagram over here. DFA diagram. 0 on 1 input. Q0 on 0, I am having Q0, comma 1. Q0 on 1, I am having Q1. Same thing, once again I am writing over here. Q0, comma Q1. It is going to Q0, comma Q1. And it is also going to Q0, comma Q1. And again I have Q1. I am going to Q pi. And the other one is Q0, comma Q1. Right? So here in the Q0 state, I got two new states. Those two new states are Q0, comma Q1 is one new state and Q1 is the other new states. So I have done for those two new states, Q0, comma Q1 on both the input symbols I have done. So I don't get here any new state in Q0, comma Q1. And then after I have done for Q1. We have done for Q1 on 0 input and Q1 on 1 input. I got one new state. That new state is nothing but pi. Something, pi is also a state, right? So we are going to apply pi. So pi on 0, pi. Pi on 1, pi. Still any new states are there? No new states. So all the states are completed. So this is nothing but DFA for transition table. DFA transition table we have constructed. By using this transition table, now we are going to construct a DFA diagram. Yes. So we are going to construct a DFA diagram. So what are the states I have? Q0 is one state. What are the states? Q0, Q0 comma Q1, Q0 comma Q1, and the other one I am taking is Q1. Q1. We can write here also. Anyway, we can write. So Q0 on 0, where it is going? Q0 on 0, it is going to 0. Q0 comma Q1. And next Q0 on 1, where it is going? It is moving to Q1. Q1. Next Q0 comma Q1 on 0, it is having a self loop. Q0 comma Q1 on 1 input, it is going to self. Okay. Next Q1 on 0, I am having some Q pi, I can take it Q pi. So where it is going? On 0 input, it is going to Q pi. Next Q1 on 1, it is going to Q0 comma Q1. Next, what are the things I have left? Pi. Pi on 0, I have 1 and 1. Pi on 0, I have 1 and 1. So Q0 is my starting state. So it is represented with arrow. And here, before that, in the transition table of NFA, let me write Q0 is my starting state and Q1 is my final state. Q1 is my final state. So Q1 is final state is nothing but it can be represented with star or it can be represented with circle also. Okay. So now we have constructed a DFA diagram. Let me check whether it is satisfying my DFA or not. Let me check it. So Q0, there are, what are the inputs? I have two inputs are there. Q0 on 0 input, it is going to Q0 comma Q1, and on 1 input, it is going to some state Q1. So Q0 is satisfying DFA diagram. Next Q1. Q1 on 0, it is going to Q0 comma Q1. Q1 on 0, it is going to Q pi. So nothing but the Q1 is also satisfied. To make this satisfied, we are going to use here dead state. That is nothing but Q pi. Next Q0 comma Q1 on 0 input self and 1 also, it is going to self state. And the next is Q pi. So as it is a dead state or dummy state or trap state, we should have the transition functions. So there are two input symbols. So we are having Q pi, pi on 0, pi, and pi on 1 is pi. So it is satisfying my DFA diagram. As Q0 is my starting state, the start state won't change in DFA diagram when we are going to convert NFA to DFA, but only the final states are going to be generated. So what are the final states? So initially in NFA diagram, what is the final state I have? Q1 is my final state. Now you check in our DFA transition table, wherever you find the Q1 state, wherever you find the Q1 state in our DFA transition table, those all states are final states. Those all states are final states. So first you need to check the NFA diagram. What is the final state? Here the Q1 is my final state. So check whether Q1 is present in any state here in DFA transition table. So the Q1 is found here in Q1 and the other one is Q0 comma Q1. Here Q0 is there, but still I have a Q1 also. So nothing but these two states are final states. So final states are represented with two circles. Final states are represented with two circles. So Q1 is my final state and I got one more state as final state, that is Q0 comma Q1. So this is nothing but NFA. The given this is DFA diagram. This is the given NFA. This is the given NFA. Now we are going to convert these NFA to DFA. We are going to convert the NFA to DFA. That is possible. But DFA to NFA is not possible. DFA to NFA is not possible. So what are the steps we have discussed over here? So first we need to construct the transition table for the existing diagram. The existing diagram is NFA. So first we need to find what are the tuples and we are going to draw the transition table. By using these NFA transition table, we are going to construct a DFA transition table. So when we are going to construct the DFA transition table, whenever I am applying on a state some input symbols, if I get the new states, we are going to find that states in transition functions. We are going to treat that as a new state. So when I am applying Q0 on 0 input, I got some state that is very new state because I don't have the state Q0 comma Q1. Next Q0 on 1 input, I got one state that is Q1. That is also new state, it is generated. So now the new states which are generated, again I am going to apply 0 and 1 input. When I am applying 0 and 1 input, if I get again one more new state, I'm going to derive that new state also. So until when I need to derive? Until I don't get any new state. See here, I got the new states in for the input 0 and 1 are the Q0 comma Q1, Q1. So those states are derived. So first what we need to take to derive this transition table? We need to start it with the start state from our NFA diagram. So first we need to start with Q0 as it is my starting state in my NFA diagram. So first you need to take Q0, then I am applying on 0 input. It is giving me some transition, nothing but some new state. That new state again I am applying 0 comma 1. Again if I get new state, so on it derives until I don't get any new state. So this is the nothing but the conversion of NFA to DFA. Yes, the next diagram is to convert NFA to DFA. So the previous one what we have did is we have constructed the transition table for the NFA. By using the transition table, we are going to write the DFA diagram. So let me construct the NFA diagram, NFA transition table. So what are the inputs I have? 0, 1 are the inputs. So there are 3 states, Q0 on 0, it is moving to Q0, Q0 on 1, it is going to Q0 on 1, it is going to Q1, Q1 on 0, it is going to Q1, Q2. Next, Q1 on 1, it is staying in the same one, Q1. Next, Q2. So where Q2 on 0, it is on Q2. So Q2 on 1, it is going to Q1 comma Q2. Let me check it. Q1 on 0, it is going for Q1 and Q2. Q1 on 1 staying in the same thing, Q1. And Q2 on 0, it is staying in the same Q2. Q2 on 1, it is going to Q1 and laying in the self loop is also there. So nothing but it is also a Q2. So Q1 comma Q2. So the next one we are having is we need to find out the transition diagram for DFA. So first we need to write the DFA transition diagram. DFA. So 0, 1. So Q0 on 0, it is going for. So we need to start it with the starting state. We need to start it with the starting state. So Q0 on 0, it is going to Q0 and Q0 on 1, it is going for Q0. So what are the new states which are arrived here? So Q0, it is matching. The new state is Q1. So Q1. So let me find out the delta dash of Q1 comma 0. Sorry, Q1 comma 1. So Q1 comma 1, what I have Q1 comma 1? It is nothing but, Q1 comma 0 we are going to find. Q1 comma 0. Q1 comma 0. So Q1 comma 0. What I am having? Q1 comma Q2. Q1 comma Q2. So Q1 comma Q2 are the states it generated on input 0. Next, delta dash of Q1 comma 1. Q1 comma 1. Q1 comma 1. What it is giving me? Q1. It is giving me Q1. So now check what are the new states it generated. So first let me check the Q0. So Q0 is completed, already existing. Q1 I had taken, that is the new state, and I generated on input 0 and 1. Again I got one new state, that is Q1 comma Q2 is the new state. So I am taking that Q1 comma Q2. So we need to find out the new states. Q1, it is Q1 here. Next, delta dash of Q1 comma Q2 on 0 input. So delta of Q1 comma 0 union delta of Q2 comma 0. So Q1 comma 0, what it is giving me? Q1 comma Q2 union Q2 comma 0, it is giving me Q2. So what I have here? Q1 comma Q2 comma Q2. But what are common here? Q1 comma Q2. Q1 comma Q2. So delta dash Q1 on Q2 on 0 input, it is giving me Q1 comma Q2. Q1 comma Q2. Now we need to find for 1. So delta dash of Q1 comma Q2 on one input. So delta of Q1 comma 1 union delta of Q2 comma 1. Delta of Q1 comma 1 union delta of Q2 comma 1. Q1 on 1. What I have? Q1 union Q2 on 1. Q2 on 1 I have Q1 comma Q2. So what is the common I have? Q1 comma Q2. So delta dash of Q1 comma Q2 on one input, it is giving me Q1 comma Q2. Check still any new states arrive. Any new states are there? No new states are there. So no new states are there. So it is done. So this is nothing but the DFA conversion. Construction of a DFA by using the NFA diagram. Check Q0 on 0 input, 0. Q0 is completed. Q1, it is the new state. I have taken Q1 as a state and I have plotted for 0, 1 inputs. 0 input and 1 input is done. And again I got, when I apply Q1 on 2 inputs, I got a new state is generated. That is nothing but Q1 comma Q2. When I apply Q1 comma Q2 on 0 input, I got Q1 comma Q2. Q1 Q2 on 1 input, again I got Q1 comma Q2. Still no new states are generated. Still even in our NFA diagram I have Q2, but when I am constructing the DFA diagram I didn't get the Q2 state. I didn't get any Q2 state. So when we are going to derive the starting state, what are the new states it is going to generate? That new states we are going to take. And we are going to find out the input states for that particular states. So now let us construct the DFA diagram. So from these NFA, what is the initial state? Q0 is my initial state. What is the final state? Q2 is my final state. So now coming to here in DFA diagram, what is the initial state? Q0 is my initial state. So what is the final state here? So in my NFA diagram, the final state is Q2. So what we have discussed, if wherever you find in any state, if you find the Q2 as a state, that's all the states are final states. So let me check here, what is the final state I have? Only Q1 comma Q2 is the final state I am having. So here Q2 is the final state. You check where it is having the Q2 in my DFA transition table. In the DFA transition table, you check whether you have a Q2 as a number or Q2 state. So here I having only in Q1 comma Q2. I don't have here and there. So this is my final state. So final state is represented with arrow or star or circle. The initial state is represented with star. So let me construct the DFA diagram. So Q0, this is one state. The next Q1 and the next I have is Q1 comma Q2. Okay, so Q1 comma Q2. Now Q0 on 0 input. Where it is going? It is going self state. Q0 on 0, it is lying in the same state. Q0 on 1, it is moving to Q1. Q0 on 1, it is moving to Q1. Next, Q1 on 0. Where it is going? To Q1 comma Q2 on 0 input. It is going to Q1 comma Q2 state. Next, Q1 on 1. It is going for self loop itself, Q1. Next, Q1 comma Q2 on 0 input. It is going for the same state, self loop. And Q1 comma Q2 on 1 input, same state. It is going. So what is the starting state in my DFA diagram? Q0 is my starting state. The starting state is not going to be changed from the NFA and DFA diagram. Only the final states are adding or not. The existing final state will be as it is, and still if we find any final states, those states we are going to get. Here, but in this diagram, I am not getting a Q2 state. But in this diagram, we are not getting the Q2 state in DFA. So, that is not the Q2 state. Here I have only Q1 comma Q2 is my final state. So, check. After constructing the DFA diagram, you check whether it is satisfying my DFA or not. Check it. Q0 on 0 input, one transition is there. Q0 on 1 input, one transition is there. Q1 on 0 it is there. Q1 on 1 it is there. Q1, Q2, 0, 1, self-like. Yes, it is satisfying my DFA diagram. It is satisfying my DFA diagram. Now check what are the final states. Here the final state is Q1, Q2 is this state is the final state. Why? Because in my NFA diagram, I have Q2 as a final state. Now check whether anywhere in the states, if I find a Q2, all the states are final states. For example, if I have here Q1, Q2, for example, then this state will also be a final state. But I don't have only Q2 in any state. So that's why only this is the final state. So it is the DFA diagram. And this is the transition table. This is the transition table. So when I am converting from NFA to DFA, the delta dash is nothing but the DFA diagram. The NFA delta is nothing but the delta transition table. So what are the tuples we are having? So what are the tuples? M dash is equal to Q dash, sigma dash, delta dash, Q naught dash, F dash. These are the final states we are going to have. So this is nothing but the delta dash transition table. Let me write here Q dash set of states. What are the set of states? Q naught, Q1, Q naught, Q2, Q1, Q2, Q1, Q2. So these are the set of states. Next, sigma 1, nothing but the number of input symbols. 0, 1 are the input symbols. And the next I have is Q naught. Q naught is nothing but what I have? Q naught is the starting state. What is the starting state? Q naught is my starting state. And F dash is nothing but the final state. So what is the final state I have here? Q naught, Q2. Sorry, Q1, Q2 is my final state. So the delta dash is nothing but here we have plotted it. So what the overview of it is, NFA DFA is, first we need to find the transition table for the NFA diagram. After finding the transition table for NFA diagram, we are going to find the DFA transition table. When we are constructing or when we are going to create a DFA transition table, we are going to find new states. Nothing but one new state is going to be generated. But that new states are going to be derived on the input symbol, set of input symbols which we are having. So until I don't get a new state, we are going to derive these. So that is nothing but by like. So we are going to construct a DFA transition table. Then after, by using these DFA transition table, we are going to construct DFA diagram. So one thing I want to tell. So NFA can be converted to DFA, but DFA cannot be converted to NFA. Thank you.